In these couple examples, we're going to be taking and doing the derivative, which is going to potentially involve either the quotient rule or the product rule or both. Just depends on the situation. So on this one, we're looking to do the derivative with respect to x of this problem. And so this is set up as a quotient rule. So you could do the quotient rule. However, I'm going to try to avoid the quotient rule if I can. Sometimes I can, sometimes I can't. But let me show you how you can on this one, where we did this last problem, and this is definitely a quotient rule. There's not much manipulation I can do to this problem. However, I can rewrite this by bringing that x to the fifth up. And the quotient rule is definitely more challenging. So if I can manipulate it to where I don't have to do it, then I will. So if I bring that up, that makes it an x to the negative 5, and now I just have a regular power rule. So if I do this derivative, the negative 5 is going to multiply, so it's going to be a negative 45. Now, be careful with when you're doing the derivative, you're always subtracting a power. Well, it's a negative 5, and you're subtracting a power. So that's going to make a negative 6 out of your power. All right. Now, I probably wouldn't leave it like this because the original didn't have a negative exponent. So I'm just going to go back and take that x to the negative 6th and bring it back down. And when I do that, I change the power again. So sometimes you can avoid it, but not always. All right, so let's say on this one, let's see if I can avoid the quotient rule. All right, so technically, again, it doesn't look like this. Your denominator doesn't have this combination where there's multiple pieces applied to it. So I can actually kind of break this up into two pieces. So here's what I mean by that. I can rewrite that as we're doing the derivative with respect to t, that's our variable. And I can write this as 3t to the 16th over t to the 6th minus 4 over t to the 6th. All right, so that doesn't seem like that's doing much for me yet, but we can simplify, and I don't have to leave this as a quotient rule. I can basically do the exact same thing that I did here. All right, so if I simplify this, I got 6 of those t's, canceling 6 of those t's, and that's going to leave us with 10. So 3t to the 10th minus 4t to the negative 6th. All right, so that's an equivalent version of this, but that screams quotient rule, where this just screams power rule. So if I can see that, I'm going to totally take advantage of that. So if I do that derivative, I'm going to be doing, bringing the 10 down to multiply. So that's going to be a 30t to the 9th minus, well, it's going to end up being a plus because we're taking the negative 6 and multiplying it to the negative 4. So plus 24t to the negative 7. All right, so just like this one, we're taking a negative 6, we're subtracting 1s, go further in the negatives. And then I'm going to go back and rewrite everything back as their positive exponents. So I'm looking at 30t to the 9th plus 24 over t to the 7th. And that would be my final answer. And it is much more straightforward than trying to do the quotient rule on that. All right, so those were a couple examples of that look like they were a quotient rule, but with a little bit of manipulation. If they're just single values in the denominator, you can probably rewrite them and avoid the quotient rule. If you have adding or subtracting in the denominator, then you're not going to be able to. So then that one, you actually have to go through all the steps to do the quotient rule.